Okay, for anyone who's still listening, we are doing the fifth whiteboard problem for chapter 16. So we want to compare the frequency, shift in frequency of a 200 hertz source if it's moving toward you at 15 meters per second versus you moving toward it at 15 meters per second. And then are they close? And then do it again for 150 meters per second. Okay, so we have a source of sound, right? That's creating waves here. That's our source. And then we have an observer. And we're given that the frequency of sound that's emitted is 200 hertz. And then we have either that the observer or the source is moving with a speed of 15 meters per second, and they are approaching each other. So we should expect the frequency observed to be greater than the frequency emitted. Okay, so we want to find the observed frequency. So our relationship for the Doppler shift, the observed frequency is the emitted frequency times the speed of sound, plus or minus the speed of the observer, the speed of sound, minus or plus the speed of the source. Okay. So let's do for the observer moving first. So our observed frequency is our emitted frequency. Again, if we're moving toward the sound, we expect the frequency to go up. So if we want this side to be bigger than this fraction has to be bigger than 1. And so we need the top to be a plus. So V plus the observer over V. All right, and then for the source approaching, okay, so we have the observed frequency is the emitted frequency. All right, so our observer is going to be at rest, so we just get V on the top. And then again, for when the source is approaching, we want, again, if it's coming towards you, you're going to hear a higher frequency. So this fraction has to be greater than 1. And so we want the minus in the bottom. Yeah, okay. And so now we're just going to plug in for 2 different speeds. Okay, so let's do when the observer resource equals 15 meters per second. So then we have F observed equals 200 hertz. Speed of sound is 340 meters per second. 15 meters per second is the speed of the observer divided by 340. Okay, and we get I already calculated it just to save us some time here because this is our 5th problem already. 208 hertz. Okay, and then on this side, we get F observed is 200 hertz, 340 meters per second, and then 340 minus 15 meters per second. Oops. Okay, and here we get 209.2 hertz. Okay, so not the same. So you get a bigger shift when the source is moving. All right, and then let's do the last part of it. If we have the source or observer moving at 150 meters per second. So again, we have the same formula, 200 hertz. We get 340 meters per second, the speed of sound, plus now 150 meters per second. That's quite a bit faster, right? We're getting comparable now to the speed of sound, so we should expect quite a big shift. Okay, and then over on this side, we have the observed frequency is 200 hertz, 340 meters per second, and then 340 meters per second minus 150 meters per second. So on this side, we're going to get 357.9 hertz, and on this side, we get 288. 0.2 hertz. So again, we get that the observed frequency of when the source is moving is you get a bigger shift than when the observer is moving. And it's interesting, right? What's going to happen when our velocity goes to the speed of sound? Ooh, it's going to get tricky there. Okay,